Space is supposed to be silent. That's not a poetic idea, it's physics. Sound requires a medium, particles to compress and expand in waves. The vacuum between stars has almost nothing. A scream in deep space doesn't travel, it simply disappears. So when NASA's instruments detected a signal, loud, pervasive, filling the entire sky, that no known source in the universe could account for, the scientists who found it didn't celebrate. They went quiet, because in science, when you hear something that shouldn't exist, the first instinct isn't wonder, it's doubt. You check the equipment, you check the data, you check again. They checked, the signal was real. In 2006, NASA launched a balloon-borne instrument called ARCADE, the absolute radiometer for cosmology, astrophysics, and diffuse emissions. Its job was precise and narrow. Measure the faint radio glow of the first stars in the universe, the earliest light ever produced by matter. To do that, it had to be lifted above most of Earth's atmosphere, where interference from our own planet would be minimal. The instrument was cooled to within a few degrees of absolute zero, sensitive enough to detect signals so faint they border on the theoretical. What it found instead was noise, not the gentle background hiss that cosmologists expected, not the known radio signatures of distant galaxies or the soft remnant glow of the Big Bang. Something else, a radio signal roughly 6 times louder than all known sources in the universe combined. Loud in a way that had no catalog entry, no name, no explanation. The team that analyzed the data spent months eliminating possibilities. Instrument error, atmospheric contamination, known radio sources that might have been miscounted or underestimated. One by one, the candidates fell away. What remained was a signal that the universe, according to every model and map astronomers had assembled, should not be producing. They published the results in 2009. In the paper, they called it simply the excess radio background. In the years that followed, others called it something else, the space roar. The name sounds informal, almost casual, but it captures something real about the discovery. Whatever this signal is, it fills space. It comes from every direction equally. It isn't pointing at a source. It isn't coming from a single galaxy or cluster or region. It saturates the sky with a uniformity that makes it deeply strange. Because uniform signals that fill the entire sky tend to be fundamental. They tend to be telling you something about the structure of the universe itself. The cosmic microwave background, the most important map in all of cosmology, is exactly that kind of signal. It fills the sky uniformly. It came from everywhere at once because it was produced everywhere at once in the early universe when matter and light finally decoupled after 380,000 years of being locked together. The CMB is the oldest photograph that exists, and it is quiet, precisely, measurably quiet in the radio bands where ARCADE was listening. So the question the data raised was simple and devastating. If the CMB accounts for the background and all known radio sources, every galaxy, every star-forming region, every active nucleus ever cataloged are accounted for, where is this extra signal coming from? 17 years later, no one has answered that cleanly. Some researchers have proposed that the excess is coming from a population of faint radio galaxies too dim and too distant to resolve individually, too many to see one by one, but collectively producing a glow that fills the sky. It's a reasonable hypothesis, but when astronomers run the numbers, the required population of invisible galaxies would itself be anomalous. More of them, and fainter than current models of galaxy formation comfortably predict. Explaining one mystery with another mystery isn't resolution. It's a different kind of problem. Others have looked at the signal's properties and considered stranger possibilities, primordial magnetic fields, vast structures of magnetism that may have formed in the first seconds of the universe before atoms existed, before any light had been emitted. These fields are theoretical, supported by some indirect evidence but never directly confirmed. If they exist at the scale required to explain the excess, they would represent a piece of cosmic history we didn't know was there. And then there are the proposals that live at the edge of what mainstream physics is willing to consider seriously. Dark matter interactions producing radio emission as a byproduct. Relic radiation from processes in the very early universe that our current models don't include. Structures or phenomena that haven't yet been given names because nothing in our existing physics framework had reason to predict them. None of these are the answer. They are directions, possibilities. The scientific literature on this signal reads like a map with many roads drawn in and none of them marked as confirmed. What makes the space roar particularly unsettling is what it implies about our inventory of the universe. For decades, astronomers have been building increasingly precise catalogs of cosmic radio sources. Every galaxy, every pulsar, every quasar that emits in the radio spectrum has been mapped, modeled, and added to a running account of what the universe is producing. The arcade signal doesn't fit that account. It suggests that the account is incomplete, not by a small margin, not by a rounding error, but by a factor of 6. Something is out there, producing radio waves, and it is larger, energetically, structurally, cosmologically larger than everything we have already found. There is a version of that realization that feels exciting. A gap in the map means something is waiting to be discovered. Science has always advanced by confronting exactly these moments, when the data refuses to agree with the model and the model has to give way.
But there is another version of it that feels different.
We have been listening to the universe for over a century. We have mapped it in radio waves, X-rays, infrared, visible light, gravitational waves. We have launched instruments into space, floated them above the atmosphere, cooled them to temperatures that barely exist naturally anywhere in the cosmos. We have been meticulous, patient, extraordinarily careful. And the universe, in response, produced a signal we had no framework to receive. Not a glitch, not a noise artifact. A real, physical, omnidirectional signal, 6 times louder than everything we thought we understood. Sitting in the data, waiting, while our models insisted there was nothing there to find. There is something worth sitting with in that, not the specific numbers, not the radio frequencies, or the flux density measurements, or the competing hypotheses in the literature, just the bare fact of it, that we built the most sensitive listening instrument we could, pointed it at the sky with the intention of hearing the first stars, and heard instead something we had no name for, something that filled the entire sky, something that, if you converted it into pressure waves in air, which you can mathematically as a translation exercise, would be an almost incomprehensible roar. Space is silent. The physics is clear on that.
And yet,
in the data, in the carefully calibrated readings of an instrument we sent above the clouds to hear the universe more clearly, something is speaking, not in any language, not toward any destination, just present everywhere at once, in frequencies we were never specifically listening for. We don't know what it is. We don't know where it comes from.
we don't know if we ever will,
But it's there, underneath everything, behind every map we've made of the sky, a sound the universe isn't supposed to be making, still making it.